up there just in case. Yeah, makes me feel good about myself. If I get bored, I can watch math videos one day.
That is so depressing. Getting excited by math videos.
And our rule from properties of exponents was when I multiplied, I'm going to add exponents if their base is the same. So for the a's, I can add these exponents and get a to the fifth. And b is the same thing. Please remind yourself that is b to the first power. So please don't forget that. So when you add that with this base of b, that will give me b to the third. Now this is technically just one term. So terms are connected with addition and subtraction. So our first term is done. And now we can move to our second term. 3 times 2 is 6. So I'm going to write a plus to once again separate them, 6. And then I'll add my exponents for my bases. That would be a to the fourth. And remember, there's a 1 here, so that would be b squared. And last but not least, to my third term, 3 times negative 5 or minus 5 will give me minus 15. When I add the exponents for the a's, reminding myself there's a 1, that's a to the third. And since there's nothing to add to b, you just keep it as b. Or you can write it as b to the first. And that is what your final answer will look like. Nice little trinomial we just multiplied into it. Does anyone think that they have a question on that problem? Okay, so that was multiplication. We know that the opposite of multiplication is division. Oh, boy, this isn't going to work for me if you guys are going to talk the whole time. Okay, so
That's all me. It's my beat.
it's fine. Yeah, it happens. I'm just throwing it out there.
It's a talkative day.
Just gotta make our way through it, you know.
Yeah, I feel you.
By talking.
So we talked about multiplying. Yesterday we talked about dividing. We called it a fancy word called factoring. So we talked about GCF. And we're going to do a lot more factoring as we go. But let's just do one GCF problem just before we start the newer stuff. Because we want to make sure we're good with the basic concepts. On Monday, and also with area and perimeter problem, we're going to find GCFs of I'll say 10,926 and 25,792, and we'll find the GCF of it. It's going to be so fun. So just get excited, guys. So right now, I'll make them more easier numbers. When I say factor out the GCF, reminder that means greatest common factor. And I give you a nice little polynomial. Let's do 12x to the fifth. We'll just keep it with one variable. Plus 6x to the fourth. Minus 18x to the third. Plus 3x squared. Sorry, that's a lot of thought in my brain. So a reminder, when you're doing GCF, kind of just do it in steps. So focus on one part at a time and see what they all have in common. So let's look at the numbers first. So these ones we should kind of be able to figure out without getting into a whole other process here. I got a 12, a 6, an 18, and a 3. What is the highest number those are all divisible by?
3.
Yeah, it's yellow. I was going to say something. Yellow out. 3.
Right.
Because it can't be, if that's the lowest one, it can't be any higher than that. Okay, and then if I have, let's see if you remember from yesterday, x to the fifth, x to the fourth, x to the third, x squared. What should I put in my GCF? Does anyone remember? Can I just yell it?
Smallest exponent.
Love it. The smallest exponent, so that would be x squared. Beautiful. Thank you so much. So once again, they all have to have it in common. That's what greatest common factor means. So if there was somewhere without an x, you couldn't take it out. But since they do all have an x in common, you take the one with the lowest exponent. Then we go back and divide. So each of these get divided by 3x squared. So I'm just going to do them in order. When I divide my coefficients. I subtract my exponents. Just as a reminder, we go back to those properties. So now I do the same thing over here. I'm going to divide by 3x squared. That will give me plus 2. And when I divide, that will give me x squared, right? Because I subtract those exponents. I just keep going. Everything gets divided by 3x squared. So that will give me minus 6x, or you could write x to the first. And then when I divide this by 3x squared, I got, please, so one thing people tend to do, they go, oh, that cancels out, right? Like 3 over 3, it just cancels. You have to put something there. So 3 divided by 3 is 1. And then x squared over x squared is also 1. So 1 times 1 is just 1. But make sure if, there's an original term there has to be something there as part of this. So just a little reminder from yesterday. Woo! Are there any questions at the current moment?
Nope.
That's just great. All right, we'll just do our new thing, but it's kind of quick because you kind of already know how to do it. It's just maybe like a little bit of a different setup. So we'll just practice a little, and that will kind of be it for today. Nothing too crazy. But once again, now that we've seen adding, subtracting, multiplying, and GCF, tomorrow we just want to make sure, like, if you see directions, you know what you're doing. Like, the one thing that messes people up is with multiplying and dividing, you change the exponents, but with addition and subtraction, you don't. So you need to make sure, like, you're okay with that general concept. So that's what we will practice tomorrow. So I'm going to go back to my directions, and I'm just going to say multiply again. Anytime I say multiply with polynomials, we're just thinking about distributing. Hey, did you guys do this ever?
No.
I said multiply that. Yeah. It's probably one of those things like you didn't get to last year, which is fine. It's just, I never know what people do. I always like to ask. So, my friends, this is multiplication, right? We have a binomial here in parentheses, and then it's next to a set of parentheses, which means we're multiplying by another binomial. So here's how we do it. We basically just take that distributing step that we did before, and we just do it twice since it's a binomial. So here's what I do. I take this first term, and I distribute it. Okay, I can do that, because that's what we just did in our warm-up. Just be careful here. 2x times x, remember there are ones there. I'm going to add those exponents, would give me 2x squared. 2x times 3 is going to give me 6x. What a day. So the issue is, before we were just distributing once. Since this is a binomial, we distribute twice. So I take this second term, and I'm going to distribute that. So it's just basically however many terms you have is however many times you have to distribute. And I'm just going to kind of make this one big old problem. So I just kind of keep extending this. 1 times x is 1x. 1 times 3 is 3. And then in the end, we do want to write things in standard form if we can combine like terms we're going to. So I do see that these are alike because they both just have regular x's, right? So my final answer will be 2x squared plus 7x plus 3. So fun. So the concept is kind of the same. It's just now instead of having one term outside of the parentheses, we had 2 terms. So you just kind of do them individually. Take the first term, distribute it, and take the second term and distribute it. And then you're good. Does anyone have a question with that concept? So let's try one more like that I'm going to kind of add to it. This is basically what we're doing today. Nothing too crazy. I always like these ones. Let's do 5x minus 7, I don't know, x minus 2. Doesn't really matter what you start with. It's just understanding, okay, I have these 2 polynomials, we call those binomials, and I'm multiplying them, because when I have 2 parentheses next to each other, that's multiplication. And the big thing to remember with polynomials is distributing. So if you can keep that in your brain, you'll be in good shape. I take the first term, and I distribute it. So a concept that we're familiar with. Just be careful, 5x times x is 5x squared. If you need to put the ones, please do so. You have to add those exponents. And then we'll kind of just flip to the next one. 5x times negative 2, just be careful with your signs, is negative 10x. And I basically just go back and do the same thing. I just grab the second term and distribute that. So however many terms you have is however many times you're gonna distribute. I'll get negative 7x. Just be careful, a negative times negative will give me plus 14. And then I can combine these middle terms because since they're both just regular x's. And my final answer would be 5x squared minus 17x plus 14. All right, can you guys try this one? Because I'm gonna jazz it up a little in a second here. Why don't we do 3x plus 4, 2x minus 5. Can you guys, if I said, hey, could you multiply that or distribute that? Can you please try that and see how you feel? Let me know if you need help. Oh. One more minute.
It's either this or work. I mean, it's more complicated to talk about it rather than just talk about
You guys know how Cyran works? Alright, so quick, so when I know Cyran, which is not that much, what it is you guys have a document for essentially right?
All right, so hopefully that wasn't too bad, because once you kind of get the idea, you just do the same thing every time, just changing numbers, right? So first term, distribute. Just make sure that 3x times 2x is 6x squared. Then I would get minus 15x. And I'll grab this and distribute that. And I'll get plus 8x minus 20. And then I see that I do have these like terms in the middle. What's negative 15 plus 8? Negative 7x minus 20. What a beauty. So can you please check that right now and see if you did okay? Does anyone have a question? I got a few more for you. I mean, we can do a million of these, but if you get this one, you can pretty much do any of them. So that's exciting. I won't make you sit here and do a million of them. Well, let's look at this one. I'm going to switch this setup a little bit. What if I said, can you multiply? Let's do, I don't like to use numbers that are too big, so I'm lazy. 6x plus 1 times, let's make this fancy. 3x squared plus 2x minus 11. That looks a little different. So over here we had a binomial times a binomial, and there we have a binomial times a trinomial. Hey, you know what the nice part is? Once you understand the concept, you do the same thing. So the concept is, if I'm multiplying, I'm distributing. So only difference here really is I start with this first term, I distribute it. It's just instead of 2 terms, now we have 3 terms. It doesn't actually make it any harder, it just makes one little extra thing to do. But I just want you to recognize that setup. Parentheses, when we have polynomials, just a whole bunch of distributing. And it doesn't really matter how many terms you have, you can distribute for days here. So just be careful with your exponents. 6x times 3x squared, remember there's a 1 here, would give me 18x to the third. So we're still adding, and when you're multiplying, you add exponents, so be careful. Next term, 6 times 2 is 12. And then we have x times x. We add their exponents to get x squared. And then we go to our last term and we get negative 66x. What a beauty. And I said, well, I'm not done because I started with a binomial and I've only used one term so far. So now I take this second term and I'm going to distribute that. Same exact process, just that one little extra term there. So when I distribute 1, I'll just get plus 3x squared plus 2x minus 11. And then we always like to clean it up, put things together that we can, combine like terms. So this is the only thing that has a cube, so that will stay out in front. So I see an x squared here and an x squared here. And that's 12 plus 3. Remember, when you're adding, you add the numbers. The exponent stays the same. You only change the exponent when you're multiplying. Then we have x is here and x is here. Negative 66 plus 2 is negative 64. And now we got that constant up here. So we're focusing on the setup, the concept, that when you have polynomials that ask you to multiply, you just distribute. Doesn't matter the setup. This is so fun. Is everyone else as riveted and excited as I am?
No way.
Yeah,
Just
I
couldn't
know.
be.
I know. It's just one of those. We just gotta just go. I only really have one more problem, and then we'll just try 2, and then we'll be done. So just bear with me for this last one. Sometimes you're just gonna kind of. Wait a second, this looks different. Oh gosh, what should I do? Now, the answer is not. I'll tell you what the answer is not. It is not 4x squared plus 9. Nope. It's not 4x squared minus 9. Does anyone think why does that not make sense? Or could anyone think of what I would do?
Would it be 2x then to the third?
Nope. Go guess, thank you. I like when I don't guess something. Yep.
2x squared minus 3.
Nope. Okay.
Oh,
Yep.
would you make 2 of them?
Oh my gosh, yes. So, remember back in the day, aka like last chapter, we said, oh, if there were parentheses and there's an exponent on the outside, we just like raise everything to that exponent. So that's not so much really chess. The difference is, last chapter, we never had pluses and minuses. It was all multiplication division. So if this was multiplying or dividing in here, go for it. You can use that property. But once you see a subtraction sign, it's out. Sorry, now you got a polynomial. You can only do that with one term. We have 2 terms. So we need to think about the concept. The concept says we have 2x minus 3 squared. And the idea of squaring something is that you take that and you multiply it by itself. So it's one of those things you just have to kind of think about. And now that you've seen it, when you see it in the future, you have an idea of what to do. But when you see a polynomial, so a polynomial means there's more than one term squared, you're going to take that polynomial and multiply it by itself. We call this expanding the binomial. So you take it and expand it to 2 instead of 1. And now that goes back to our good old distributing. Take your first term, 2x times 2x is 4x squared. Just be careful, that's like the big part. People forget the squared and it messes you up. And then we have 2x times negative 3 is negative 6x. Then we distribute the second term. That gives us negative 6x as well. And then just be careful with signs. That's plus 9. And I would combine like terms in the middle to get 4x squared minus 12x plus 9. So just kind of make a note to yourself or write that down so you can refer back to it. When you see a polynomial squared, do not just square everything. You take that polynomial and you multiply it by itself. So we call that expanding the polynomial. So right now, we know how to add, subtract, multiply. We know that special case of GCF, we're gonna do more factoring. So the stuff we do when I say factor next week is we kind of go from this and we go backwards to that. So that takes a little bit more work. So we'll do that kind of on its own. So tomorrow, we'll review. Monday, we'll just do some kind of like special problems, some specialty problems where we use all this stuff. And then Tuesday will be a quiz, so please just make sure if you have questions you ask before then. And then we'll start the other dividing stuff after that. And that's all I can think of in my brain right now. So I'm gonna give you 2 wrap-up problems. So can you try these? Excuse me. And then, we'll just go over them quick and then we'll be done for the day. So these are our wrap-up problems. All right, so one's just like the general idea of what we were going over today. So can you guys do 5x minus 2 x minus 1? And then number 2, I gotta throw a fun one in here. So let's do, I don't wanna make it too crazy, so maybe I won't make it. Let's do 2 times x plus 4 squared. That's what I'm just gonna say simplify. Yeah, we'll just keep it there. I was gonna do some crazy other stuff. I'll save that for the future.
I was thinking Toy Story. You know that baby?
Yeah, those facts, yeah.
So I'm gonna work on this part first. Okay, so I'm gonna keep my outside. I'm gonna get rid of these ones. What is it to? Before I use this outside component, I'm gonna combine. I have a couple.
It's just here. It's like time. It's weird. Sorry. I don't want to do it.
Maybe against like another school, like race them. Do you do that this year?
I just like.
Say like 2 more minutes, then we'll kind of wrap that up. And then I'll have 2 minutes again.
I just want to get faster. I was surprised to see that kid more.
Finishing up your project.
All right, let's just go over them, you tried them, we'll see if you did it right, if you didn't, then we'll fix it, and you'll have some more practice tomorrow. Sorry, so I was kind of just like, power through these. So we understand the concept, hopefully, of distributing, so I take my first term and I distribute it. Just be careful with your exponents, that's the main thing here. That would give me 15x to the third, plus a 30x squared, right, because that has a first power and that has a first power, minus 5x, or you can write 5x to the first, go for it. And then I do the same idea, I just do it with the second term now. Minus 6x squared, minus 12x, plus 2. Well, that's a long old problem, I'll look this one over. And then I'm going to combine like terms, so I would have 15x cubed. I'm going to combine my squareds. I have positive 30 minus 6 would be plus 24x squared. For my x's, I have negative 5x minus 12x would give me negative 17x plus 2. And that would be your final answer. What a beauty. And just as a reminder, we should be starting to remember those names. That would be called a cubic, because the highest exponent is 3. Polynomial with 4 terms. Just as a heads up. This one I kind of put 2 steps to. You can do it 2 ways. What I would do is I would do 2 and then x plus 4, x plus 4. The second I see that something is squared, I just expand it. Okay, so if I see x plus 4 squared, write x plus 4, x plus 4. I kind of just threw this one at you, so I'm not sure what you did. But what I'm going to do is I'm going to distribute these first, and I would get x squared plus 4x plus 4x plus 16. I like to combine like terms. And then I'm going to multiply everything by 2. So if, that's not right, Mr. Sherman, trying to talk and write at the same time. X plus 32. Obviously, I gave you 0 guidance on this, so if you did it this one wrong, that's okay. Excuse me. But do not multiply in first. Remember, this was kind of an order of operations problem. I threw it out here just to see if you would get it. When you are talking about order of operations, you always do the exponents, aka expand it, before you multiply. So you cannot multiply and then do the exponent. That doesn't make sense. So if you got caught in that, and I kind of threw it at you and made it a little tricky, don't worry about it. But just make a note to yourself. You have to do the exponent first, so you have to expand it first, and then start to multiply. If you wanted to multiply by 2, that's fine. You would just do it in one of the parentheses and then distribute to the other one. So you kind of just do 2 things at a time. So that one, I kind of tried to give you a little. Sometimes math teachers do that.